What I want to talk about now is static variables versus non-static variables. So here we have seen those instance fields that we are creating. They don't have the word static. So just remember, static means shared. Non-static means non-shared, specific to an object. So like those methods, they were non-static. That means they're not shared. That means they are specific to an object. If you need to set the name or set the amount or get the name, get the amount, you have to have an object so you can call that method on it. The same way, those instance fields that we've been creating in our classes, they are not static. They're not shared. If I create many bank account objects, each one is going to have their own unique name and their own unique amount. So can I create some static instance fields? And the answer is yes. What would be a piece of information that is shared among all bank account objects? Well, maybe the name of the bank. So things that might be shared are the bank name, the name of the bank. So MCC Bank. All the bank accounts in this bank belong to one bank, MCC Bank. Maybe the routing number. So every bank has a unique routing number, whatever. So this is information that's shared among all bank account objects. So every time you just go to a bank and create a bank account, you just provide them your name and how much money you want to deposit, and automatically they can create a check for you, give you a checkbook that has the name of the bank and the routing number on it. Okay. So how can I access these instance fields that are static? Well, there are two ways that you can access them. I can go to an object like B, and well, first I need to write methods. So let's talk about methods first that we can write to access these static instance fields. Okay. So the methods can be static or non-static. So you have the options. So I can say public, static, string, get bank name, and that will return bank name. Because the variable is static, I can access it from a static method. I can also access it from a non-static method. So just get B name, let's call it B name, and return bank name. And both will work. So this is unique to static variables that you save, your static instance fields. You can access them from a static, in a static context or non-static. What does that mean? That means I can just go to the bank account class, the whole class in general, and say, get me the bank name. Okay, just like math dot something. Okay, or if I have a specific object, go to the object and I can say, get me the bank name using the non-static method that I wrote. So I can access it. If I write a static method, it'll work. If I write a non-static method, it will also work. Okay. Now, what I also want to talk about is another use for these static variables. Another example, for example, if I have, like, if I'm storing the name, the amount, and also I'm storing, let's say, account ID. Okay. Now, this is the account ID for the bank account. This is not something the user chooses. So when you walk into a bank, you'll tell them your name, how much you want to deposit. You are not going to tell them what ID you want them to give you. You know, your account number, basically. Account number. You're not going to give them that. They assign it to you. So how are they going to assign it? Like, how are they going to know, are you supposed to get account number 1000 or 1001? Or like kind of like your banner ID. When you walk into college and you request to be a student, they assign you a banner ID automatically. So how do they do that? Well, one of the things we can store is a static variable, maybe next available ID or number. Variable is really long, so maybe let's call it next. Oh, no. Okay. And beginning of times when all the world is starting, the first account number is going to be 1. And so when you come to create a bank account, you need to get an account number. So your account number be taken from where? From whatever is available. So if the next available one is 1, you want to assign that to yourself. Next account number. First bank account that gets created will get the number 1. Well, we don't want to reuse 1, so what we do is increment 1. So now I got assigned 1 and I incremented the next available to be 2. The next time someone comes to create an account, they will say, can you get me the next account number that's available? And it's 2, it will get saved, and then you just need to make sure that you increment it. And we need to make sure that in all our constructors, we have those 2 pieces of code. Okay, so let's try testing that. So let's here, we created bank 1, bank 2, and let's print their account numbers. So let's come here and let's say system.out.print 1a dot. I made it private, so let's write a method, get account num. So we want to call it on A and we want to call it on B. So A got created first, it should have 1 and B should have 2. So let's just write get account number. Public int account number. And so I will find that the first account got the number 1 and the second account got number 2. And if I create more accounts, they will each get their unique account. I just want to show you what's kind of happening in the background in RAM. So when you call a static variable, the first time when we call the first bank account object. So when we went and we said bank account A equal to new bank account, all that. What happens in the background is that the constructor gets called, and immediately when the constructor is getting called, the first thing that's happening is that in RAM we allocate space for all the instance fields that are there, whether they are they are non-static or they are static. So immediately in RAM, I'm going to allocate space for a name, amount, account number. So I'm going to get name, amount, and account number. Okay, that's the first thing. And then I'm going to also allocate space for my bank name, routing number, and next account num. So here's my bank name, and it's going to get the name MCC Bank. And then I'm going to also have my routing number, routing num with the number in it, and then the next available ID, and it gets a 1. Okay. And then the constructor gets starts executing, and it's going to save the name and the variable in there, the amount in there, and give it an account number. So this is what's happening when A gets called. So when A is done, by the time A is done, I have here dog, I have here 10, and the next available is 2. Sorry, the account number, this is the account number, it's 1. And the next becomes 2. So this is what's happening when bank account A gets created. Now, when I call bank account B, when I try to create B, again, it's going to go to the instance field and it's going to check what do I need to create. So it needs to create a name, an amount, an account number. So it's going to create a space for name, one for the amount, and one for the account number. And then it's going to look and say, okay, we also need to create bank name, routing num, and next account num, but it checks and says, oh, those are static. Those are shared. That means I need to check if they have been created before. And so it goes and checks, have any bank account object before created these? And it does. It finds that they have been created before in a shared space and says, oh, okay, so I'm going to be looking at these. And so when it comes to do in the constructor, it sets the name to, you know, cat, the amount to whatever the amount was. Okay. And then it says account number equal next account number. So it's going to check it's 2. So my account number is going to be 2. And then it says next account number plus plus. So now I'm going to change this to 3. So these are the static variables. They are the shared ones. Okay, they are shared space. They are shared by everyone. And so basically this is the difference between a variable that is not shared versus a variable that is shared.